So we're looking at frequency histograms and polygons. This first one is just going to be a very basic one where we're looking at displaying data or organising the data. Okay, so we're talking about frequency tables using to organise it. Now it says frequency tables used to organise large sets of data. This is not a large set of data. With large sets of data, we're talking like thousands of people. Okay, this is not a large set of data, but for the purposes of what we're trying to do, it's sufficient. Okay, first thing we're going to do is put it in a frequency table. Now, my guys, when they get their booklets, yes guys, you are very lucky, already have this here, but it's not filled in. Exactly what's on the screen is what they get. You guys have a textbook that, oops, I just moved that. Sorry everyone. I'll just try and move it back. There we go. There we go. Let's do that. There we go. Okay. So yeah, you guys have to actually draw that table. Okay. That's all right. I scribble all over the place. So you need that table. Okay. Frequency table. What you need is a score, a tally, and a frequency. Now, as you move through, especially once you start doing cumulative frequency tables, you will not draw the tally column anymore. The tally column is there at the moment just to make sure you know what the hell you're doing. Make sense? Okay. Now, there's two things I would recommend that you do as soon as you've drawn your table and before you start entering the data into the table. There's two things that I would do. First one is this. I'd highlight that. That tells you how many you should have at the end. This is the scores, the number of wickets that Mitchell has taken in his last 20. So you know that you should, if you counted all these, you should have 20 pieces of data. That make sense? That's a good habit to get into so that you know, once you put it into your tally, if you have a look, you should be able to have 20 pieces of data. If not, then you might have missed one. Cool? All right. Oh, and you'll notice I'm talking even while you're working because I don't want the video to just be, blank spots. So if you need me to stop or slow down, just say so. All right. Now, it's interesting. If you read in the textbook, it actually says draw up a frequency table with 5 columns. You're actually only doing 3. Textbooks have a tendency to make mistakes, and they fix them in 2nd edition or 3rd edition. You're only doing 3 columns. So don't look at that, it said 5 columns. So don't look at that and say, oh my God, what are the other 2 columns? Yeah, don't worry about it. Now, they've already given you 6 rows. Now, normally with data, they won't give you how many you've got to do. You've got to work it out. How did they work it out? How did they work it out? Have a look at the data. What do we got? What's the lowest? Yeah.
0.
Lowest is a 0, highest is a 5. So we'll go 0, 1, 2, 3, 4, 5. Make sense? Okay. That's the second thing you should do before you start entering data. Make sense? First thing, know how many are in total. Know how many data points or bits of data or things, whatever you want to call them. Next thing, work out what your range is so you know what you're putting into your thing. Have your scores down there. Now, normally with a frequency histogram, frequency table, try not to, even if there was no 3s in there, imagine there was no 3s in this data, I would still put a row with 3. Okay? Don't go 0, 1, 2, 4, 5 just because there's no 3s. Make sense? Have the 3 in there as well and just have 0 for the tally. Cool? Or for the frequency. Alright. Now we're up to entering data. I know I'm talking about stuff that you've probably done before and you probably already do, but I just think it's important that we just make sure that we're all on the same page. My expectations of you, while not being your actual teacher, but by being awesome, my expectation would be that you do something similar to this. You don't have to do it exactly like this, but this is how I would expect people to do it or thereabouts. Okay, first number is 2. Cross it out. Put a tally, cross it out, or use a highlighter, or circle it, or put a little tick next to it, whatever. Okay, it doesn't matter. The reason I do that is I know I've done it. Because if you're doing 150 bits of data, and someone comes up and goes, Barry, how you going? you're going to look up and you're going to lose your spot. Okay? Unless your name's not Perry, then you'll just ignore him. Okay, 3, 0, 1, 0, 2. So you go through and tally them up. Doesn't actually take that long when you're only doing 20 of them. If you're doing 100 of them, might take a while. You guys all know how to gatepost tally?
Yeah.
Yeah? 4 and then the gatepost. 2.
Fifth one is always the one first.
Yeah. There we go, I'm done. Okay, why do they do it? Why on the 5th one? Why not on the 4th?
Like Roman numerals, it changes at the 5th one.
Well, why 5? It's the same reason we've got base 10, actually, instead of base 2 or base 6. Babylonians use base 6. We use base 10.
Universal.
Who's 17? Anyone here 17?
That's good.
So you're that old? Is anyone here 16? 16 is that old. Perry's that old. That's 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Babylonians use base 6. That's why we've got 60 minutes, 60 seconds, 360 degrees, 24 hours. All using multiples of 6. We use base 10.
10 seconds.
The French, at one stage, used base 20. Why? Why base 10? I ask you, why base 10?
10 centimeters. You got 10 fingers.
Thank you, we've got 10 fingers. Why did the French use 20? They didn't want shoes. Toes as well, fingers and toes. Lovely. So why do we use the gatepost with base 5? Well, sorry, not with base 5, but with 5.
It goes across.
Yeah, that's a good way of thinking of it. 4 and then that one cross, it's 5. Basically, it's because it's easy to count. It's much easier than having 9 of them than in a line, because it splits it up into smaller groupings, which makes it easier to count.
Define the group.
But we do the 5s because 5 then 10, 15 then 20. Which, because we work in base 10, that's how our brains work. Make sense? Okay. But that's why it's not 2 in a line. So it's a nice one. Alright, so you've now tallied up that thing. Before you put your frequency in, can I suggest this? This is another suggestion. I'm doing lots of suggestions in this. Before you put that in, add your frequencies up. 5, 10, 14, 17, 18, 19, 20. I'll just write the 20 down there. Does that tally up with the amount of data that I should have? Yes. Woohoo! I've probably done it right. Cool. I just like to put little checks in there so that I can make sure that I'm doing stuff correctly. Okay? I don't want to get to the end and then find that I've stuffed up. So 5. Now write your frequency down based on your tallies. And like I said, I know I'm doing this as stuff that you've already done before, but it's just important that you have a way to double check your work. And it doesn't take very long just to add them up and make sure that you've got the right amount. And it will save you grief later on. Because if you get your tallies wrong, which means your frequency will be wrong, which means when you go to find your median, it could be wrong, or it will be wrong. When you go to find your interquartiles and your lower quartile and your upper quartile, it will be wrong. When you go and calculate your standard deviation, it will be wrong. When you go and find your mean, it will be wrong. Because it's all based on a wrong base. Now, having said that, if you've written that down and got it wrong, us 4 maths teachers then go through all your other answers and work out if it's right based on the information you gave us. And then we can give you some marks because at least you know what you're doing. You just can't count. Okay? Well, it's not that maths isn't your strong point, it's just that you're an idiot. But we can deal with that. Alright, so, everyone happy with that? You're now going to put that data in a bar graph. So, once again, what goes on which axis? We talked about this the other day. Horizontal axis is always the
score.
Starts with in, ends independent. Thank you, it's always the independent variable.
Dependent variable goes to the y.
Yes, Anything you calculate, my science lecturers tell me this, because, well, they tell all the students, because we've got a whole bunch of like ag students and viticulture and all that sort of thing, and equine science and all that, the horse people. And then you got me sitting there who's a maths teacher, and they all look at me and go, how do I graph this? What's a line of best fit? So yeah, independent across the horizontal. Anything you calculate, which is dependent, because it depends on what you use to calculate it, is the vertical. Okay, so the score is independent of the frequency. Okay, the score is the score. But the frequency depends on how often that score happens. So it is dependent. So we go through and do it. So now they're doing 1 centimetre columns with gaps. Do you guys know how to do a bar graph?
Yeah.
Do not do it like that. Okay? Don't do it with no gaps, and if it's too late, fix it. You're going to have to. If you do it like that, it is not a bar graph. You are making sandwich, yes. It actually is a different graph. What sort of graph is it?
It's a column.
Bar graphs, column graphs, same sort of thing. It's not that. It becomes like a cumulative frequency graph. It becomes a
continuous set of.
Yeah, well, we actually use it when we do. My mind's gone, by the way. We use it when we do. Oh my lord, ogives. Okay, we use, and we'll show you ogives later on. But with bar graphs and column graphs, what you do is you actually start. You can actually put. If you're doing it as 1 centimetre columns, what you do is you measure every half centimetre. Okay.
That's where you start the graph.
And that's where each column should be. Is it? Well, if I do that, isn't that going to touch again?
Yeah.
We don't want that, do we? What do we want?
The 0.
I have to pause this in a minute. It's been 12 minutes.
This is from the indication to the 0.
We normally keep those in the middle. So what you do, how many zeros did we have, by the way?
We had 5.
5. And then leave half of one of them. Gap. How many ones did we have?
5.
How many twos?
3. 1 and 2.
You need gaps in between. Okay. Everyone happy with that?
Yep.
Okay. You need gaps. If you're doing 1 centimetre column wide ones, do a half centimetre gap. All right.